All right, y'all, video 2, let's go. Number 14 says, which postulate or theorem can be used to prove triangle ABC congruent to triangle DCB? And so what I notice right now is I have two sets of sides marked congruent to two sets of sides in the other triangle. And then I have this overlapping piece. Using the reflexive property of congruence, we can say that that is that segment, those back up to each other, and those are the same length in each picture. And so that is going, or in each triangle, so that is going to be side, side, side. Side, side, side would prove those triangles congruent. Which postulate or theorem can be used to prove, this should be different wording, by the way, I needed to fix this earlier. Which postulate or theorem can be used to prove these triangles congruent if these lines are in fact parallel? So that these symbols right here do not mean congruent. Those are triangles. I'm going to make that a little bit bigger so you can see that. That means that those lines are parallel. So it's saying which postulate or theorem can you use. The first thing I'm going to do is I'm going to recognize that these cross at point N. So y'all are so used to adding vertical angles. I'm going to do that from the start. And then so now I've got an angle and a side congruent. So I'm missing one more thing. So there are two places you can add alternate interior angles. If these lines are parallel and this is my transversal, then I could add an angle at angle O, and angle L would be congruent. So if I did it that way at angle O and L, then you would say angle, angle, side. But you can also do, if you had done it here, 1, 2, 3, 1, 2, 3, at M and at K, that would also be angle, side, angle would also work. So if this were a multiple choice test, would give you credit for either of those. All right, what are the values of X and Y? I like to put a box around what I'm looking for. So the first thing I notice in this triangle is that it is isosceles. It does not have these marks on here for fun. It has a set of two legs that are congruent to each other. And so I can set 3y plus 7, this leg, equal to this leg, 2y plus 12. And that's what's going to allow me to solve for y. So y is equal to 5. Y is equal to 5. So immediately I know it's either going to be this one or this one. So I can go ahead and process elimination, get rid of the rest. And then I also need to solve for x. And so since those are the legs, I also know that the base angles are going to be congruent. So here's my base. So the base angles are 37, and then this would also be 37. Those base angles are congruent. So how do I figure out what is left for x? In a triangle, we have a 180-degree budget, so I'd go minus 37, and that is equal to 106. So that is going to be answer choice B. I found the value of X, and I found the value of Y. Okay. Number 17 says, in the diagram, BD and BF are mid-segments. B to D is going to be a mid-segment, so it's parallel to this side, meaning that these are midpoints. And it says that BF is also a mid-segment, so let's color code that. BF is here, so I'm going to go... BF is a mid-segment. Okay, so I can mark that as the same here. Here's BF, 1, 2, 3, 1, 2, 3. And I'm going to mark this one. Go back. I'm going to highlight. I think that'll make it easier. Here is the green segment, BF. It is parallel to CE, and I know that it's a mid-segment, so I get to say that this point is the midpoint. And so this segment is the same length as that one. This segment is the same length as that one. It says find B to D and find C to E. B to D is going to be this value right here in blue, B to D. B to D is facing the same way as the 15, and it's going to be half that third parallel side. So it's going to be 15 divided by 2. 15 divided by 2 is 7.5. So BD is equal to 7.5. So I found BD. Now I just need to find CE. Where is CE? CE starts here and goes to here. It faces the same way as the 6. That's the mid-segment. So to get CE, I'm just going to double 6, which is 12. So there is BD. There is CE. All right, this one does not have a picture, but it says, what is the supplement of 120 degrees? Supplementary means that they add up to 180. So I'm going to subtract off what I've spent. That would be a 60-degree angle would be supplementary to 120. All right, now we're going to be using the hinge theorem, this diagram on the right. The hinge theorem states that if you have a side and a side, so there's the 10, there's the 10, congruent to a side and a side, I'm going to use the reflexive property here, so I get to add that these are overlapping and thus congruent. And and the angle in between is different. So this is 50. This is the included angle is 50. This one, the included angle is 60. Then the longest side is going to lie opposite the biggest angle. Remember, we say big side, big angle. So that means that this piece, 3x plus 2, is going to be greater than 2x plus 6. So let's go ahead and write that inequality. We know for sure that 3x plus 2 is going to be greater than 2x plus 6. So we're going to get our variables on the same side. So x must be greater than 4, which is what A says. That's just the hinge theorem. All right, what is the shortest side in this picture? Well, the first thing we need to do if we have a triangle is make sure that we know all the missing pieces. Right now I only have 2 sides, or 2 angles of the triangle. So what I'm going to do is I'm going to subtract the 45 and the 65 to see what my third angle is, and that is going to give me a 70-degree angle. Before I make comparisons between the 3, I need to have all 3. So we know that it says, what is the shortest side? We know that the shortest side is going to lie opposite the smallest angle. So we say big side, big angle, small side, small angle. So what's the smallest angle in this picture? 45 degrees. What does that open up to? That opens up to this side, AC. So the shortest side is going to be AC. If we didn't have at least 2 out of the 3 angles, we wouldn't have been able to add any information, and we would have had to say cannot be determined. But we were able to calculate that third angle. All right, it looks like we're finding a range here, and I've got a side and a side congruent to a side and a side of another triangle where the included angle is different. So what is a possible side length for AC? Well, AC is going to be the bigger side. AC has to be greater than DF. I know that because 50 is bigger than 45. So DF is currently at 15. So AC has to be greater than 15. What is the only value here that is greater than 15? This is equal to 15, so that cannot be the case. Those would have to both be the same angle. The included angles would have to be the same. So 17 is really my only option here. All right, number 22. In the diagram, which of the following is not a possible measure for angle DCB? So again, I think we're going to use some more hinge theorem here. This is overlapping at a side, so I'm going to use the reflexive property there. There are 2 sides congruent to 2 sides of a triangle where the included angles are going to be different. I know that because this one opens to 15, this one opens to 13. So I know that angle 35, that 35-degree angle, is going to be greater than whatever this angle is here. So 35 is going to be greater than my question mark angle. And so it has to be smaller than 35. And so it says, which of the following is not, oh wow, so I'm looking for, this is tricky, which of the following is not a possible measure? So I'm looking for ones that are, to answer this question, which ones could be less than 35? 27 is less than 35, 30 is less than 35, 35 is not, 20 is, 34 is. So the one that is equal to it is the 35-degree angle. Those couldn't both be 35 because they would both need to open to 15 if that was the case. So that would be C. Okay, that would be answer choice C. It's kind of confusing. All right, I've got some more hinge theorem going on here. So angle 1 and angle 2, we're making comparisons about them. This one opens to 10, while this one opens to 12. So I know that that must mean that this one is the winner as far as which side is greater. So that means that angle 2 would have to be, the measure of angle 2 would have to be greater than the measure of angle 1. So which answer choice says that? That would be D. All right. List the sides in order from the shortest to the longest. So again, we need to find our missing angle first. 180 minus 60 minus 40 gives me 80 degrees to spend here. If I'm looking for the longest side first, I'm going to look for the biggest angle first. So the biggest angle goes with the biggest side. So EF is going to be the longest. EF would be the longest. Our medium amount would be across from the 60. That would be GF. It does not matter if you say EF or FE, GF or FG, that names the same segment. And then our smallest amount, our teeny tiniest amount will fall across from the teeniest tiniest angle, which is 40 in this triangle, which is going to make that smallest side, that shortest side, EG. Make sure you pay attention. It wanted longest to shortest. Longest to shortest. So that would be my list of the sides. Stay tuned for part 3.